Hi guys, and welcome to the third lesson on chapter 3, sequences. I'm loving your answers to the competitions, making it a little bit more fun. So today's competition is 5 hidden shapes, and they're all coloured pink. You've got to get up bright and early to get this because there's some very keen ones out there. And I am so pleased to be able to see all of you at school, either this week or your lessons next week. I'm very much looking forward to seeing every single one of you. Okay, so today we are doing geometric sequences, or GPs. So last lesson was arithmetic sequences, APs. Okay, so what is a geometric sequence? Well, if we look at this sequence here, to get from one term to the next, I'm sure you can see what you're doing. You are multiplying by 2. This sequence here, to get from one term to the next, you are dividing by 2 or timesing by a half. Okay, and the numbers can be negative as well. Okay, so to get from one to the next here, you are multiplying by -2. So each time you have to be multiplying by the same number. So 3 examples of geometric sequences: timesing by a half, timesing by 2, and timesing by -2. Okay. So what is a geometric sequence? A geometric sequence is any sequence where the difference from one term to the next goes up by a common ratio. So we call the number you're timesing the common ratio R. Okay, so let's look at how we write down the rule for the nth term of a geometric sequence. Okay, the nth term of a geometric sequence. So we will have the first term is A. The second term is A times R. Yeah, so this is your first term. This is your second term. So your third term, so we're timesing by R to get from one term to the next, common ratio R. So your third term times by R, you get A times R times R, so AR squared. The fourth term, again, you times by R, so you get AR cubed. So this is your sequence of numbers. So this will carry on going through the same, just multiplying by R each time. So guys, what's the rule for the 10th term of this sequence? Can you see the connection between the term and the value of R? The term and the value of R. Think of this one as R to the 0, because R to the 0 is just 1. So the 10th term will be AR. The power is 1 less than the term itself. So the 10th term, 1 less than the 10th term, is AR to the N. So AR to the 10 minus 1, AR to the 9. So the nth term of a geometric sequence will be AR to the power 1 less than the term itself. That is important. That is what I want you to write down, please, in your notes. The nth term of a geometric sequence. I'll just go through that one more time. First term, second term, third term, fourth term, to the nth term. Okay, so you can see this is your second term and your first term. Okay, so write everything that's down here, really, really important. Right, comments on my videos, much appreciated, please. Some of you say I go a little bit too slow. Okay, so just speed up if you need it speeding up. You just fast forward. Okay, let's look at an example. Okay, find the 10th and the nth term of this geometric sequence. So, first of all, what is A and what is R? You got it, guys? A is your first term, and R, well, to find R, I'm going to do 6 divided by 2. You can probably see this, but this will help you later on when we get into algebra. So we're multiplying from one term to the next by a common ratio R. So what will my 10th term be? Well, it's going to be AR to the power 9. So A is 2, R is 3. So it's going to be 2 times 3 to the 9. You'll need your calculator now, so I'm just getting mine. Work it out on your calculator. I'm going to do 3 to the power of 9 and times it by 2. So I get 39366. Okay, and the nth term, the rule for the nth term will be AR to the n minus 1. So in this case, 2 times 3 to the n minus 1. You just leave it like that. Yeah, you're not going to expand that if you don't know what n is. Right, what about this B? We want to find, I'm just going to do the nth term now. What's the nth term? So we need to know A, the first term. We need to know our common ratio. So our common ratio will be our second term divided by our first term, which is -1/2. So the nth term is AR to the n minus 1. So that's 80 times -1/2 in brackets to the n minus 1. Okay, so next, another example. Okay, getting a little bit harder now. The second term of a GP is 4. The fourth term of a GP is 8. The common ratio is positive. Find the 11th term. Okay, so I know the second term, i.e. AR to the 1, is my second term, is 4. I know my third term is, my fourth term, this is my second term, this is my fourth term. Remember, AR to the n minus 1 is your nth term. Okay, so 1 less than 2 is 1, 1 less than 4 is 3. Okay, so I've got 2 equations with 2 unknowns, A and R. So what I'm going to do is I'm going to divide the one equation, I'm going to divide the second equation by the top equation. So I get this. So I'm dividing the second equation by the top equation. Like simultaneous equations, I can add, subtract, multiply or divide. And what you see here is that my A's will cancel and R cubed divided by R will be R squared. So R squared is 4. So R is the square root of 4, which is 2. And you're told that the common ratio is positive. So it has to be +2. So we've got R. So now let's just plug that in to find A. I'm going to plug it in to this equation here. Yeah, so I've got AR to the 1 equals 4. I know R is 2, so A is also 2. So I've now got my my A and my R. So the 11th term is A R to the n minus 1. So A R to the n minus 1. So get your calculator. 2 to the power of 10 equals times a 2 is 2048 as my answer. Okay, next question. Okay, question 3. We're going into algebra now. So I've got 3 terms of a geometric sequence, and I know they're all positive, and I want to find the possible values of what x could possibly be. Right, now, I know that my common ratio is the same. Going from one term to the next, I'm timesing by r. And to find r, I divide the second term by the third term. And I could have also divided the third term by the second term, yeah? So I'm multiplying by r in each case. So this divided by this is r. This divided by this is r. So these two are equal. So what I do, as I'm sure you've now realised, I just put them equal to each other and I solve that equation. So pause the video, you do that and see if you get the same as me. So the answer I get, I times both sides by x and bring the 3 across. I'm going to get my quadratic, take it all to one side. Okay, I am going to factorize now. Okay, I have made a mistake somewhere here. Can anybody spot my mistake? The mistake is that this was not a 3. Sorry guys, this was a 6. Apologies there. Okay, right. So now I'm going to solve this equation. It will factorise. That's why I realised there was a mistake there, because it didn't factorise. X and x. 2 numbers that multiply to give me 18 will be 6 and 3. I want the 6 to be negative. So I've got x to be 6 or x to be negative 3. However, I'm told that all the terms are positive, and this was my my sequence was this 3x x plus 6. So taking x to be 6, I've got that. So this is my solution to the first 3 terms. Okay, and you can see that r is going to be 2. I'm not going to take this one here because that would give me a negative term for x, and you're told that all the terms are positive. Okay, now it asks you, the question asks to find the 10th term, so you just put a is 3, r is 2 into the formula for the 10th term. I'm sure you can do that. The answer is 1536. Okay, next. Example 4. And this is my last example before I set you the work. Oh, yeah, it is. Sorry, I'm just checking it's still working. Yeah. Okay. Example 4. Find the first term in the GP to exceed 1 million. Okay. the first term, this is going to keep on doubling, so I can see my A is 5, my R is 2, 10 divided by 5 is 2. Now, I know the formula for my nth term is ARn minus 1. Okay, and I want to find n now. I want to find which term, okay, which term will be the first term to be bigger. When will this be bigger than 1 million? Okay, so let's plug in A and R, and I'm trying to solve this now to get 1 million, to be bigger than 1 million. What's my value of n? Okay, I'm actually going to look at to get 1 million. What will n be to get 1 million? So I'm actually going to solve this. Rather than solving inequality, let's just make it 1 million first of all, equal to 1 million. Right, well, the first thing I'm going to do to both sides is divide both sides by 5. So I can see that I would get this divided by 5 is going to be this. Okay. Yep, that's correct. So how do I find n? How do I n to the power? What do I do? What's the key to find n? Well, when the unknown is the power, the thing I have to do is take logs of both sides. So I'm going to log this side and I'm going to log this side. Okay, and and then the rule of logarithms means I can release the power. Yeah, the power will now come to the front of my logarithm. And I now have this. Okay. Now, I'm going to divide both sides by log 2 and then add 1 to my answer. So n will be, I divide log of this divided by log of 2, add 1. And I just plug that into my calculator to get my answer. I'm just going to pause. So I get on my calculator, I get 18.6. If your calculator is like mine, I do log to the base 10, but it doesn't actually matter what base as long as the base is the same in both of them. And I get the answer to be 18.6 something, something, something. Now, so that's my value of n. Now obviously n cannot be a decimal, it has to be a whole number because it's the value of the term. So the term is the first, the second, the third, etc. So if n was 18, my term was going to be less than 1 million. If n is 19, which is going to be my answer, if n is 19, it's going to be, if I put that into the formula of 5 times 2 to the 19 minus 1. Yeah, I'm putting it into the 19th term. So I'm putting it into here. So n is 19, a was 5 and r was 2. If I put it into here, I'm going to get a value bigger than 1 million. And you can just check that on your calculators, that's what you get. So I'm going to do 2 to the power of 18 equals times by 5, and I get this answer. I get 1310720. So just over 1 million. So that's the first term. When n is 19, the 19th term will give me the first term to exceed 1 million. Okay, play that again to you if you find that difficult. It is difficult. There's also an example in the book, okay? If you want to follow, if you prefer to follow examples in books, on page 68, example 11. It's a different example. I purposely try and do different examples. So what work am I going to set now from exercise 3C? It's all of this work, please. Okay, that's your work. Send it to me with your 5 solid or flat shapes to enter the competition. Take care. See you soon.